Example 9 says use the lowering power formulas to lower the power on sine to the fourth x times cosine squared x. So sine to the fourth of x is the same thing as sine squared x times sine squared x. And then we have times cosine squared x. So we're going to have to use the lowering power formulas multiple times. So that is going to equal, if I sub in the identity for sine squared x, that's going to be 1 minus cosine of 2x over 2. And I'm going to write that again since we have sine squared x twice. And then cosine squared x we can rewrite as 1 plus cosine of 2x over 2. Okay, so if I notice that I have a 2 in the denominator of each of these things, so if I factor out all the 1/2s, I'd get 1/8, and then inside the parentheses, I'll just rewrite all of the numerators. Now, the last two terms here, that is a difference of squares, and so I could FOIL that, and that would give me 1 minus cosine squared of 2x. And I can use the lowering power formula again on this thing. I do want to be careful though, because notice that the angle here is 2x instead of just x. So I want to be mindful of that. So if I use the lowering power formula again, I'd have 1 minus the quantity 1 plus cosine of 4x over 2. And then I have 1/8 times 1 minus cosine of 2x. I'm going to change the 1 into 2 over 2, and then I'm going to distribute the negative sign into both of these. And I'm also going to, at the same time, split this up into two fractions. So I'm going to have minus 1/2 minus cosine of 4x over 2. And 2 over 2 minus 1 over 2, that's going to change into 1/2. Now, both of these terms have 1/2 in them, so I'm going to factor out 1/2. So I'll have 1/8 times 1/2 times 1 minus cosine of 2x. And then inside here, since I factored out 1/2, I will be left with 1 minus cosine of 4x. Okay, so now 1/8 times 1/2 is 1/16. And now I'm going to FOIL these two things. So let's see, I get 1 times 1, which is 1. And then the outer terms, I'd get minus cosine of 4x minus cosine of 2x plus cosine of 2x times cosine of 4x. And there's not really anything else we can do to combine any of those terms inside of the parentheses since none of those are like terms. So I'm going to go ahead and just box this as my final answer. Example 10 wants us to prove that tangent of u over 2 is equal to sine of u over 1 plus cosine of u. So in this example, I'm going to start off with the left-hand side. And I know by the reciprocal identity that tangent of u over 2 is equal to sine of u over 2 over cosine of u over 2. And so that step was by the reciprocal identity. And then I'm going to do something again that's kind of slick. I'm going to multiply both the numerator and the denominator by 2 times cosine of u over 2. And if we do that, we get 2 sine of u over 2 times cosine of u over 2 over 2 cosine squared of u over 2. And that step we got by multiplying by fancy 1. Okay, now hopefully the numerator looks kind of familiar to you, and that looks very close to the double angle identity for sine. So remember that sine of 2 times theta is equal to 2 times sine of theta times cosine of theta. And the only difference is that instead of theta, we have u over 2. And so you can think of this as theta here. And so we can substitute the numerator there with sine of 2 times u over 2. And so this thing ends up simplifying to sine of 2 times u over 2 just simplifies to sine over u. So this is going to equal 2 times sine of u. And then the thing in the denominator almost looks like one of the identities for the double angle of cosine, but it's not quite exactly what we want it to be. And so the way that we're going to deal with that is I'm going to subtract 1 here, but I'm also going to add 1 here. And that way we're going to get what we want out of this thing here. And so off to the side here, I know that cosine of 2 theta is equal to 2 cosine squared theta minus 1. And then if I just replace theta with u over 2, then we're going to get actually, let me rewrite this below. So the right-hand side would be 2 cosine squared u over 2 minus 1, and then the right-hand side is going to be cosine of 2 times u over 2, which that simplifies to just cosine of u. So we have 1 plus the highlighted thing becomes cosine of u. I am not sure why I added that 2 there. That 2 should not be there. So we have sine of u over 1 plus cosine of u. And now this is equal to the right-hand side. And so we are done with that. We kind of had to do some slick stuff here. And the slick stuff was multiplying by this fancy 1 here And also, we had the 1 plus and the minus 1 here, so that was kind of by like adding a fancy 0. It just takes practice, and you'll get used to these types of things as you get more practice with these types of proofs. So in the previous example, we went ahead and we derived the formula for tangent of u over 2, and we found that it was equal to sine of u over 1 plus cosine of u, which is also the same thing as 1 minus cosine of u over sine of u. I won't derive the other two formulas for you, but these make up the half angle formulas. And something that you want to note when you are dealing with the half angle formulas is that you must choose the plus or minus sign on these two formulas based on which quadrant the angle u over 2 lies in. So that's something to keep in mind as you are working on these questions for the half angle formulas.